You are sitting across the heavy desk in a high-stakes technical interview, and the prompt seems deceptively simple. You are asked to choose between tools that appear identical on the surface: string versus string builder, array versus array list. This design feels redundant. A modern programming language appears to require two completely different ways to format text or make a simple list. Even Java's strict object-oriented nature seems conflicted. A language designed around complex objects still relies on raw primitive data types like int and boolean. Beginners often fall into a predictable trap here. They memorize textbook definitions and bullet points to pass the test, missing the mechanics happening beneath the surface. Mastering Java requires stepping away from rote memorization. The language is built on an architecture of duality, a constant war in your computer's memory between rigid security and dynamic flexibility. The foundation of this architecture begins with primitive data types. These are the raw materials of Java. Because they lack complex object features, they execute with maximum speed and absolute efficiency. However, advanced Java structures only accept complex objects. Our raw primitive lacks this structure, so it bounces off the gateway. Java bridges this using wrapper classes. Encapsulating the primitive in a larger shell grants it object properties, trading a fraction of speed for compatibility. That newfound flexibility introduces risk. In environments where an application relies on a data point remaining absolutely constant, like a tax rate or a server port, the ability to modify an object becomes a vulnerability. To counter this, developers deploy the final keyword. Applying final acts as an emergency brake, locking the data down and preventing any subsequent code from overwriting that value. Choosing between a raw primitive, a flexible wrapper, or a locked-down final variable dictates the foundational processing speed and structural vulnerability of the entire application. This tension between security and flexibility scales up when handling text. A standard Java string is strictly immutable. Once created in memory, its contents cannot be changed. Immutability provides specific security benefits. When multiple processing threads access the same string simultaneously, the system remains stable because the text is guaranteed to stay predictable. But consider the breaking point. Imagine an application forced to update a single string of text 10,000 times a second, perhaps tracking a rapid stream of financial data. This grid illustrates memory capacity. Since standard strings cannot be modified, every update spawns a completely new string, choking the system with dead data. String Builder is the dynamic alternative. It edits the original text in place, modifying its shape and clearing the memory bottleneck. Opting for String Builder over a standard string is an architectural requirement for preventing memory leaks in high-performance applications. When we scale up to grouping vast sets of data together, the physics of memory allocation become even tighter. A standard array is a concrete, fixed-size box. It is incredibly fast to read, but physically impossible to expand once created. Conversely, an array list acts like a living organism. As data demands dictate, it dynamically grows new facets and shrinks when items are removed. The array list functions as an abstraction of the fixed array. Under the hood, it maintains its own internal arrays. When it runs out of space, it creates a larger one, moves your data over, and destroys the old one. Beyond how much data you store, you also have to dictate exactly who owns that data. This diagram contrasts ownership. Non-static variables are individual, private data instances held by distinct nodes. A static variable is that single, shared instance in the center, governing the entire class globally. Navigating this duality of size and scope allows a developer to precisely manipulate the total memory footprint of their software. Returning to the interview room, realize these questions are proxies for high-level engineering judgment. The interviewer is testing your ability to evaluate a highly specific engineering problem and select the exact tool required to solve it efficiently. Java intentionally provides this duality. It hands you granular, absolute control over how the machine behaves. Every time you choose an array over an array list, or a static variable over a non-static one, you act as an architect. You are balancing memory limits, maximizing processing speed, and strict safety protocols to keep the machine running perfectly. Keep that blueprint in mind for your next exam. Subscribe to the channel, and we'll keep mastering Java 1 minute at a time.